Yes, so hi everyone, my name's Kevin Baldwin. I'm a lead engineer at EDF Energy. I've been there for about 2.5 years now. And I work for a team that is doing a lot of this. I was going to go into detail, but it's actually quite dull. So everything that we do is quite dull. So anyway, let's make a start. So what are UK energy interactions and why are they complex? So to answer that question, we've got to jump back to the amazing time that was the 1990s. Hands up if you're a 90s child. Yeah. And we need to start with a little brief history of the UK energy market. So, and just to start with, I've only been at EDF for kind of 2.5 years. So if there's any errors in any of this, that's my kind of get out of free jail card. I don't know enough. Anyway, so before the 90s, there was a group of large monopolies that was responsible for setting the price of energy in the UK. For gas, it was British Gas. For electricity, it was a bunch of regional electricity boards. And in the 90s, privatization and deregulation of the energy industry kind of started. The big kind of upshot of that was that consumers could start to choose who supplied their energy. So rather than who supplied your energy being dependent on where you lived, as a consumer, you could choose any supplier. The problem with that was that the monopolies were still so large, they had so much control over the market, and they could essentially shut new entrants out. And in 2001, Ofgem launched a set of kind of market trading reforms that were aimed at kind of stopping that behavior. Since then, the cost of energy has been set largely by the market. The big thing that kind of this is all focused around is the fact that consumers can choose who supply their energy. So that means that you've got lots of people switching supplier. Excuse me. They've got choice in where they get their energy, which was a big change for the industry. It meant that we ended up with a bunch of new kind of players, people that were responsible for different aspects of that kind of journey. So you've got generators, you've got suppliers, you've got people trading energy, you've got meter operators, you've got all sorts of people going on, and their jobs were to fulfill different parts of that kind of those requirements. So, for example, someone switches supplier, that generates a whole load of data that needs to go between all those different companies. So to answer what are UK energy interactions, it's really how all of those parties communicate with each other. Why are they complex, right? So there's a couple of different reasons for that. And if we think about what's happening here, we've got a load of different parties that are supplying kind of industry data. And EDF, as an example, is interested in that data. EDF uses that data for a whole host of different things, using it for forecasting demand, for compliance reasons, for trading, buying energy upfront, these kinds of things. So internally, there's a lot of different teams and a lot of different services that are interested in that data. Second reason that they're complex is if you think about when this happened, it's the 90s. So the technologies that were used were very much a product of the 90s. So my favorite is CSV-like data. It's not CSV, it's like CSV, but it's not CSV. Kind of variable format file lengths, this kind of thing. And most of it was files as well. So you're dealing with FTP, SFTP, VPNs, network shares, all this kind of stuff. And also, we're talking about the 90s through to kind of 98. It started off with not a lot of standardization. So different data flows had files in different formats. The electricity kind of industry seemed to be better than the gas industry. Over time, the standardization has gotten better. And actually now we're in a place where there was a new service that came out last year, I think, called the faster switching service. And that's all webhooks and kind of cloud services and HTTP. But, you know, it's taken kind of 30 years to get there. So this is kind of a little diagram that kind of illustrates some of the things that are going on in the kind of post kind of 2000s EDF. You've got these data flows coming in the form of files. You have to do a bunch of different processing with that data, and then ultimately it gets put into some kind of shared storage. And then each of these teams, each of these services that's interested in that data is going off to that same storage location and polling for changes and asking, has that data changed? Have we got a new file? Can I do something with it? And the issues with that are kind of, you know, obvious, really. You've got really tight coupling between the service that's responsible for ingesting that data and the teams and the services that are consuming it. Any downstream change in the excuse me, any change to the file ingestion service means that there needs to be changes to those downstream services as well. It's really hard to manage that change. It's hard to know who's involved, who's actually looking for that data, who's working with it. And you're working with flaky protocols, things like FTP. You have scenarios where you try and get the file and it's gone, or something happens with the network and you're losing data, these kind of things. So that's the kind of the preamble out of the way. So what we've been doing at EDF is, you know, with all these problems, the fact that technology has moved on, we've been looking at ways to internally improve how we manage that data and how we manage those processes. And we're doing that with EDA, which is event-driven architecture. So I'll start with what is an event. This is probably going to seem like a bit of a kind of a simplistic place to start, but it is important. So you can think of an event as being the kind of the opposite side of something that we're more familiar with, maybe. So when you're making an API request, you can think of that as a directed kind of call, right? So you're saying, do something, create a user. The flip side of that is a user was created. And this is the kind of observed model, right? So something's happened, I'm interested in that happening. Some key things about events. We want events to be immutable, so events shouldn't be changing. It's something that happened in the past that the past can't change. Events need to hold universal meaning for domain experts. So what we're trying to get here is all of the information that you find within an event should describe what happened, and it should be relevant to all of the people that consume that event. Events are emitted regardless of whether or not people are going to subscribe to them and actually use them. We still emit them. And anyone handling that event, listening to that event, needs to be working in an idempotent kind of way, right? So, for example, you create a user. If you receive that event again, you don't want to create the user a second time, right? So you look for ways to manage your system so that if you receive that event, you don't do the same thing again. And events are asynchronous. So you can have one publisher can put out, you know, one event. Lots of consumers can consume to it. You can have lots of events being fired off at the same time. All of this is happening in a non-synchronous way. Right. So a little fictional event, just a kind of example. Typically, events are JSON. We use Event Bridge, which I get into in a little bit. But if we're looking here, I'm trying to illustrate the idea that this event has happened in the past. So the electricity meter was read, and the payload to that event is using the domain language of the business domain. So rather than talking about IDs and kind of nondescript things like that, we're using the terminology that the domain experts would understand, right? So an MPAN being the ID of the electricity meter and kilowatt hours being the value that's been read. So how well do industry data flows fit with an event model? The answer is pretty good, actually. If you kind of look at what we've got here, we've got standardized data. It's well documented. It's understood by domain experts. Each data flow contains all of the relevant information. They obviously represent point in times, things that have happened in the past, and they're immutable. You can't, once this file has been created, once it's been published out, it doesn't change. It's not all good news though. As I mentioned, we've got older file-based systems, and the problem with these starts to become around how do you model your events internally, because these file systems these file notifications tend to be batched events. So it's lots of meter readings, lots of things happening, and you're publishing out one file that may cover a day or a week's worth of data. So it doesn't quite fit. The newer services, like the one I mentioned, faster switching, that's a true event model. You've got webhooks being fired every time someone switches user, every time someone switches supplier. You've got a webhook that goes out in real time. So that's a more modern system and a service that we built over the last kind of couple of years. But all of the older systems, we're dealing with files, so it's a lot harder. So I wanted to present a kind of example architecture. So this is something that it's a pattern that we use quite a lot. And this is kind of relevant to a piece of work that's kind of ongoing at the moment, really. So it's dealing with DTN flows, which are, again, electricity data flows. And we've got an ingestion trigger, right? So something is happening that is giving us this file. And we have to do the processing still. But we are using a state machine in this model, and we are doing a whole bunch of different things here. We're scanning the file for a virus. We're saving the file to a local S3 bucket, doing a load of conversion on the file, so turning it into different formats. Some of our consumers downstream have different requirements on the file format. So rather than making them do that work, we're doing the work internally. And off the back of that, we publish an event. That event, you could argue, is not, it's, how to kind of articulate this. In this case, we're publishing an event that says a file has come into our system, which is a kind of odd event. It's not really a domain event. It's not like a meter reading or something else. But the value that we found in this is that we can slowly, piece by piece, modernize our internal systems, right? So we can say, here's an event that contains all of the information that you were familiar with before. But you don't have to change too much in the way that you consume that, right? You can just push that team, push that service forward a little bit. We found it really powerful, and it's really starting to help us to kind of isolate the boundaries between our teams and the boundaries between our services. So here is an example of the event that I'm kind of talking about. We're using EventBridge. So this kind of schema is very much tailored to EventBridge. We've got the detail type describes the name of the event. The source describes the service that issued the event. And then the detail field is all of the kind of the domain specific things that are important about that event. We've started using a schema kind of internally that we find helps to model or helps teams kind of integrate with this. So we're using this idea of metadata and payload, right? So the metadata is information that might be useful retrospectively or for doing things like in this case where we're doing transaction tracing across our services, and we're putting all of the trace information into a metadata. But the payload is where all of the domain kind of specific language lives. And in this case, our state machine has, our state machine has done a whole load of processing, and it's converted the file formats, and has got a load of information about that file. So we're publishing that information out as part of the event. So we've got some header information, some footer information, some file type information, and then the location of the files. So this means that instead of teams having to know where the file exists, you're told where the file is, right? One of the great things about this kind of format is, as a consumer, when we're working with EventBridge, it means that subscribing to those events is really, really easy. The language that you use to kind of set up that filter or set up the subscription of what events do I care about matches, A, it matches the domain language, and B, it matches the structure of the event itself, right? So here I'm saying I'm interested in the DTN file notification published event that's come from that service, and I'm only interested in the files that are of that type, right? It matches exactly the event schema. Yes, JSON rules match the event schema. Easy to debug, easy to see who is interested in which of our events. So EventBridge as a service supports 28 different targets, right? So a target is who can subscribe to the event, what kind of AWS service can subscribe to these events. These are some of the more interesting ones. There's a whole load of other stuff on there. You can kick off pipelines and send stuff to CloudWatch and all sorts of stuff, but these are some of the more interesting ones. We're using predominantly Lambda. We're at EDF, we're heavily kind of into the serverless world, so Lambda is a big part of what we do. But yeah, you can kick off an ECS task, spin up a whole Docker container, do what you like with it. API gateway and API destinations are really, really useful. So we can have services that are less kind of modern and may not even be hosted on AWS, easily subscribe to our events by setting up essentially a webhook, and we publish the event directly there, and they do what they want with it. So this is the kind of a view of what the old world looked like. We've got one big industry data handler. It's tightly coupled with all of the teams that are interested in that data, all the consuming teams. It's super hard to manage change. It's brittle, and knowing about new files it's not kind of responsive. It takes a long time. Teams are really dependent on each other. So if the reconciliation team wants to kind of make a change, it has to kind of know about the data structure of the file system. If you've got a new team that comes in and goes, oh, I'm interested in that data, then they have to spend a lot of time going, how do I interact with that file system? You know, what firewall rules do I need to set up, and how do I get your data, this kind of thing. And on the flip side, if you've got changes that you want to make to that data handler, you want to change the file system and that kind of thing, then you have to publish that change out to all of those other teams. The new model after this change, we're in a scenario where you've got loosely coupled services. The services have got complete kind of ownership and accountability over how they implement their event subscriptions, right? So If they want to work with SQS because for whatever reason, or they want to work with SNS, they want to work with API Gateway rather than something else, then they've got complete autonomy because we're just publishing out an event. We've got a really clear boundary to our service, and they can choose how they work with that, how they subscribe to it. It's immediate, so whenever those files come in, an event gets published straight away, and you've got a massively simplified kind of consumer architecture. So what lessons have we learned? Agreeing on principles and guidelines for the event structure is really important. You've got lots of teams that are working together that are dependent on those events. You want to have a set of principles and set of guidelines for other teams that are going to want to start publishing their events, right? Having a consistent way of transaction tracing is an example of that. Understanding your consumers' needs is really important. You want to be publishing events that are relevant to your consumers. So it's not just what's the name of the event, what it is, but what's that payload look like? What are the use cases that your consumers have for your event? So you need to be sure that you're putting the right information into those events. At EDF, we've got a bunch of really, really good architects. So our architects really work as the kind of domain experts. And we lean on them really heavily to understand what all of these consumers are and what they need our events for. So having people that you can lean on to model your events correctly has been really important. Publishing a catalog of events as well. So EDF's a large organization. You've got a lot of services, a lot of teams. Not everyone knows who works on a particular service. So having a catalog of events and schemas is really important so that teams can discover your events and can subscribe to them and start consuming them. As I said, transaction tracing is much harder. We use a kind of cloud provider for all of our kind of observability, and they don't really support event tracing out of the box. And we wanted to be able to look at how does an event flow through our system and who's consuming it, where are the bottlenecks, this kind of thing. So we had to put work in ourselves to kind of to do that, and it's much harder to do. If you think about a normal web request, you've got a API endpoint, you might have some lambdas backing it, you've got some databases. It's easy to kind of synchronously trace across that, but with events, you're kind of fanning stuff out, and it's easy to lose that information. But the big thing really is that EDA is a really powerful way to manage change and risk. We had a scenario with a service that, the faster switching service again, after that went live, there was a downstream consumer that had a bug. And it was really easy to manage that risk by switching the subscription off, right? So the events were still going to the event bus. And the architecture meant that they would build up, the downstream service could fix their problem and then resubscribe to those events, and would just replay the events back onto that event bridge. And that problematic subscriber could then just consume them all and get their state, get their situation in place. It's also allowing the organization to move forward kind of progressively. EDF's got a lot of different teams, a lot of different kind of people working on different systems. Having this model where you're publishing out the information that other people might be relevant to, but other people might be interested in, but it's kind of relevant to you, allows you to build these really clear boundaries between whose responsibility it is to kind of manage that data, whose responsibility it is to ensure it's correct. which is really, really powerful for large organizations. That is it. I don't know how long. I think I rattled through that probably. Like, yeah, thanks for listening. Any questions?